Okay, welcome everybody. Okay, so today we're going to talk about strings, arrays of strings, command line arguments. We've got a lot that we might not get through all of it today. We'll see how we go. Okay, but lots of exciting stuff. So last lecture, which was yesterday, we did a recap of arrays. We looked at one-dimensional arrays of structs, and then we started with 2D arrays. And these are all things that you're going to be practicing in tutorials and labs and, you know, the assignment as well. So today we'll do a bit of a recap on 2D arrays. Then we'll introduce strings. Now, strings are really great because strings allow us to have text in our program. So it's going to really be great. Anything we don't finish can be covered in the next lecture when Sasha gets back. So don't stress if we don't get through everything I've got in these slides. So you can access the week 4 live lecture code. As always, there's links from the course website as well. Now, assignment 1 has definitely been released, and there's also an assignment 1 walkthrough video. So definitely, as soon as you can, if you haven't already, go and watch that walkthrough video. It really steps you through getting started with the assignment. Okay, so don't leave it to the last minute. Get started, and then you'll be able to go and get help as you need it, you know, from help sessions and things like that. So just another thing I wanted to say is that there are subsets and or stages, and each of the stages will tell you their sort of dot level, like 1 dot will be stage 1, you know, and stage 4 I think is 3 dot. So don't panic if you think, oh my goodness, I'm getting to stage 4 and it's really hard. Yeah, stage 4 is going to be quite hard. So for now, just really concentrate on stage 1 and getting that done. And, you know, oh, the sound is very low, is it? Is everyone finding the sound low? Okay, I'll try and talk a bit louder. Let me know if there's problems. So yeah, make sure you do get started soon. All right, so let's talk about 2D arrays. So we looked at 2D arrays yesterday. So just a reminder, because they're brand new, with any array, we need to choose one type that we're going to store in that array. And in this example, we're having an array of ints. The name of the array, we've called it number grid. This is like the variable name. And then we've got 2 dimensions here. We've got them in these square brackets, which we use for arrays. And this means we can visualize it as having 3 rows and 5 columns. Okay. And we can visualize it like this. Here we've got 3 rows, row 0, row 1, row 2. And in every row, we've got columns. And in this case, we've got 5 columns. And just like with any array, our indexes start with 0. And if we've got something of size 5, there will not be an index 5. All right. Now, when we're accessing elements inside a 2-dimensional array, we have to provide 2 indexes to get to our individual integer. Okay. So here I've said go to index 2, 3 and store the value 42 in there. So when I go to row 2, index 3, I've put the value 42 in there, and that's how I've stored this value. Now, if I did something like, I don't know, number grid at index 1, I don't know, 1, 2, equals 3, we're going to be going to row 1, we're going to be going to column 2, and we're going to be making that equal to 3. If I do something like, if I try and go to, I don't know, row 1, actually, if I try and go to row 4, index 1, which sometimes people might do accidentally, what's this going to do? If I go to row 4, index 1. So I say number grid 4(1) equals 72. Well, this is going to, we're going to go out of the bounds, and on DCC, we're going to get a runtime error and it will tell us. On another system, we might end up overwriting precious data or doing something even worse. So yeah, no such row. People can accidentally do this sometimes when they get these indexes around the wrong way. All right, so they're just the basics of how we can access the individual elements. Then we talked about, well, how can we go through every element of the array? For example, if we wanted to print it out, we certainly don't want to hard code this. We want to use loops. So we looked at using nested loops with one index from the outer loop controlling, well, in this case, it's controlling the row indexes, and the other index in the inner loop, in this case, it's controlling the column indexes. And we could set the row to 0 and the column to 0, but then in this inner loop, we keep incrementing the columns. So we're staying in row 0, the inner loop is incrementing the columns, and we're going through all the columns in the first row. Then when this inner loop is finished, we print out a new line and we increment our row counter, here. And then we set back, most importantly, we set back our column to 0 again. So it'll start on the next row at column 0, then 1, then 2, then 3. We increment our row counter, we set col back to 0, and we can go through it like this, row by row, column by column throughout those rows. And most of our examples where we're going through one by one, we'll be doing it like this, row by row. Occasionally, we did see one example yesterday where we wanted to go column by column, but unless you have a specific reason to do that, it's best to go row by row. Okay, so we'll just write another function just to make sure we sort of really are on top of it. Oh yeah, and we didn't get time to do sum diagonal top right. We did sum diagonal top left, so we'll finish that off. And once we do that, we'll start with a new topic. Okay. So all right, we've got this array from yesterday. Now, for all of these examples, I've just kind of hard-coded it so everything just works for 2D arrays of this particular size and dimension. So everything in here is hard-coded to work for 2 rows and 3 columns. So this is my variable name, it's grid. Rows is 2, cols is 3. I've put this data in it. So I've got 3, 5, 1, 2, 4, 9. And these are my row indexes. These are my column indexes. Okay, so it looks exactly how I've typed it in, really. So the other day we looked at printing, which I just showed you. We looked at summing things and all of that sort of stuff. I'm going to comment that out for now. And we looked at reading stuff in as well. I'm going to comment, well, actually, I might just go move it down the bottom for a while to keep it out of the way with all this other commented code, just so our main doesn't look too messy. I'll put that down there. Yeah, so if you go back and watch yesterday's and you want to, you know, just easily bring that code back, you can. Okay, so we've got this code. When we run this currently, let's compile it. And let's run it. It's just printing out the grid in the way I just sort of showed you. Now imagine I want to create a new grid or a new variable, and I'm going to call it grid2. And it's exactly the same size. Can I do something like this? Can I just say grid2, I'm declaring it, I'm making sure it's the same size, and it equals grid. Is this going to give me a copy of the array? Can we do this with arrays? Just make one equal to the other? Because if I have int x int x equals 9, int y equals x, that works fine. But yeah, when I've got arrays, I can't just do this. I need to create my own copy. I need to go through and actually copy things from one array to the other. Yeah, even the editor's screaming at us, no, you can't do it, you can't do it. But let's see what this says. This might give us array initializer must be, it's telling us that we can't do it. Okay, so how do we do it? Well, basically we're doing it, we've just got to step through our first array. So when I do this here, oh yeah, rows and cols have been defined up here as 2 and 3. They're up the top. Okay. So when I do this here, all I've done here is created a chunk of memory, and let's clear this. All I've done here is created a chunk of memory of the right size. So this is grid 2. This is grid 1. So all I want to do is I want to go through every element in grid, and I might as well start on the first row, first column, and I want to just go and put it in this grid over here. So I want to copy the 3 in, then the 5, then the 1, then I want to go to the next row, copy in the 2, then the 4, then the 9. That's all I want to do. Now, I certainly don't want to do something like this. I could, this would work. Grid 2 at index 0, 0 equals grid at index 0, 0. Grid 2 at index 0, 1 equals grid at index 0, 1. I don't want to do something like this. This works, this would copy it, but I'd have to do that for every element in the grid. And imagine we've got bigger grids. We want to do this with some sort of while loop. So the while loop is going to be quite similar to what we've seen before. So I'm going to start at row 0, and while I've still got more rows, I'm going to go through each column. So I'm going to start with column 0, and while I've still got more columns, I'm going to keep going through the columns. And for every row column coordinate, I just want to take grid 2 at that particular row and column and make it equal to grid at that particular row and column. So this code is pretty much exactly the same as the code we wrote to print out a 2D array, except instead of doing a printf here, we've got this line that's copying from one array to the other. Okay, and it's doing it row by row. Now by the end, we should have 2 grids. At the moment, I'm trying to copy an array just to show you how you would do it and how you can't just write grid equals grid 2. So what would you do instead? Not for any good reason, just demonstrating how to code stuff for when you do need it. All right, so by the time I've done this loop here, I should have a copy of grid 1 in grid 2. Let's check it out. Let's just check it works. Yep, both of them have the same data. They're 2 separate copies. Yay. How would I make sure, how would I fix my style in terms of putting this into a function? What would my prototype be, and how would I use the function? Because, we don't want all of our code in the main. So when I'm calling print grid, I'm just passing in a grid. what am I passing into this one? And is it returning something? What's the return type? Yeah, so what I can't do, I can't return a two-dimensional array. I can't do anything like this. Copy array. I can't just pass in the first grid, create a copy, and return it or anything like that. I have to pass in both of my arrays. Okay. I'll call this grid copy. So I'm going to need a prototype like this. I pass in both of the arrays, and inside the function, it can actually go and fill in all the values. Actually, I'll grab this. Okay. There we go. So yeah, I can go and put all of this code into my function. Now in my function, I haven't called it grid2, I've called it grid copy, but it can do it all from in here, okay? And when I call it, I just say copy array. I pass in the two arrays, grid that has all the data in it, and grid2 that has the data that I'm copying it to, all right? So this should do exactly the same thing. And this is because, which we have talked about this, when we call functions to, when we pass arrays into functions, we actually pass them, when we pass them in, we don't pass a copy. We're not copying all this data. This function will have access to the original arrays that are stored where all of main's data is kept. So when we pass in this second grid, it won't have any values in it. It'll go through and it will update all of these values. It'll copy them over, and it's copying it into the original array, right? So that's just important to remember. And when the function finishes, it no longer has access to these arrays, but these arrays are both arrays that belong to the main function, and they've both got their data in them now. Okay. So that's copy. Should we just check this compiles and works before I move on too quickly? Okay, yep, same thing. We've just moved it into a function. All right. Now, yesterday we also looked at this diagonal, and people very quickly realized that if I'm working with this diagonal here, I'm dealing with index 0, 0, then 1, 1, then 2, 2, then 3, 3. Okay. All right. Actually, somebody in the chat's asking a good question. Often with the one-dimensional arrays, we didn't put a size in, and we would have an input to the function with saying what the size was as well. Like we had prototypes like, I don't know, our function might have int size, and then it might have int array like this, and there's no size in here. When you're working with two-dimensional arrays, you do need to have a set size for one of the dimensions. You're able to have nothing for one of them, but you have to have the size here in the second one. And I'm not sure if that's what you mean. So the way we're going to do it for now is that we're always going to put these sizes in, and this limits us. This is going to limit us because when we wrote our single arrays functions like this, we could pass in arrays of different sizes and, you know, our function would still work. Here we're kind of limited to these hard-coded sizes. Okay, we could leave this size out and pass in arrays with different numbers of rows, but, you know, it gets a bit Gets a bit messy. Okay. And we can also, pass in, sorry, I'm thinking and erasing at the same time. It's not working for me. I can always pass in variables and, only use part of my two-dimensional array, but for now we are going to put those sizes in. All right, so the other day when we looked at our diagonals, these diagonals, the indexes were 0, 0, 1, 1, 2, 2, 3, 3. And we were able to do this a couple of ways. The most obvious way was to put if conditions in. So we did our normal two-dimensional sort of while loop, like nested while loops. But we had this condition in here. So instead of adding every single element in the 2D array to our sum, we just checked, well, if our row is equal to column, we're going to add it to the sum. Now today we want to do the other diagonal. When we're doing the other diagonal, let's go back. We've got a different pattern. So we want to go through and make sure we're only summing up elements, this element, this element, this element, this element. Now these elements, well then obviously not at 0, 0, 1, 1, 2, 2, 3, 3. This one here is at row 0, column 3. This one is at row 1, column 2. Row 2, column 1, row 3, column 0. Can anyone see a pattern? I can see someone in the chat has seen a pattern already. But yeah, one of the patterns is, so yeah, these all add up to 3. The sum of these indexes all add up to 3. What's so special about 3? Well, 3 is basically size minus 1. So yeah, we can use something from that. We can see that pattern and put this into our code in a number of ways. We could do it like this by doing the two-dimensional, by doing the nested loop approach and going through every element and checking whether we want to add it to the sum or not. And here we would say, instead of if row equals col, we would say if row plus col equals size minus 1. We could do that. And now this is only going to add or sum up those items that are along the diagonal. Aha, I've got to return the sum. There we go. And if the answer's right, it should be 15. Ah, someone's asking about a for loop, which I'll talk about next. So yeah, this is correct. We got a 15, which is correct. We could have also done it by just purely generating the indexes we're interested in, like we did the other day for the other diagonal. So I could just say, if I go grab this, all right, this was doing the other diagonal. We generated index 0, 0, 1, 1, 2, 2, 3, 3. Here we don't want that. If we're at index 0, what do we want? We want a 3. If we're at index 1, we want a 2. So the second index is going to be, well, I think somebody already put it. Yeah, Kenneth and human being wrote size minus 1 minus the index, which is correct. So well done to both of you. So we could put, let's go back down here, size minus index minus 1. Okay, and that's going to be the right formula. You can go and sort of step through it. That should also give us 15. Okay, somebody's sort of asking now about for loops. So let's just quickly turn one of these into a for loop. If I want to turn, let's just turn this into a for loop instead of a while loop. Now, the first thing you do is change the name while to for. Okay, that part's easy. But with a for loop, we put the initialization of the loop counter in here. Now, it's still done once before the loop starts, but we put it in here, and we put our increment here. It's still done at the end of each loop. It's still exactly the same as a while loop. We're just putting all of this stuff about how we control this loop counter into this part here. And it can be helpful in that we're less likely to forget to increment our variable. We're less likely to forget to initialize our variable when we do it like this, but it's the same sort of thing. So in C, a for loop is really just the same as a while loop, but slightly different syntax. It has the same sort of power. So we could do it like that. It would be the same thing. Okay, so that's 2D arrays. You'll be practicing them a lot more. Let's clear your mind for a second. Reset it, give it a break for a second, and we're going to start talking about a new topic, strings. So yeah, if you think about whenever you're using a program or you're on the internet, you've got text everywhere, right? There's lots of text. We've had no way to really work with text. We could print out things like hello world, but we couldn't actually store them in a variable and do anything with them. Okay, so yeah, strings is really going to open up our programs to do a lot more. So what are strings? Well, in C, there is no type that is called string. Like you can't, you can write int x to declare an integer. You don't write string x to declare a string. A string is a collection of characters. We can store collections in arrays. So in C, a string is basically an array of chars, but to make it a proper C string, we've got this special null terminator at the end. Okay, so we've got our collection of chars with a special char at the end that tells us when the string is finished. So why do we do this for strings? Like when we've got an array of integers, we don't have any special character at the end telling us when the array of integers is finished. We store a variable with a separate size. Now with strings, imagine I wanted to create an array for somebody's name and they're going to enter their name. I have really no way of knowing how many letters are going to be in their name. They could type in Sue and it's only got 3 letters. They could type in, I don't know, something that's not Sue with more letters. Richard, whatever. I don't know. So I would have to store, I'd have to work out how many letters they typed in and keep track of how many letters were in their name for their first name. I'd have to keep track of how many letters are in their last name if I read that in, how many letters are in their address. And we've got this, then we'd have this explosion of all of these integer variables keeping track of the sizes of all of our different strings, which are all different sizes. So this is just an easy way. We don't need a variable to keep track of the size of our string. We just know when we get here, we're at the end of the string. So this is like a stop sign saying stop. There's nothing else in this string. Okay, so that's the null terminator. Now, if you don't have that, you don't actually have a string. You've just got an array of char, and you will need some sort of variable or some way of knowing how long it was. Okay. Right, so yeah, if I want to store the word dog, we might look at that and think, well, I need an array of size 3. No, I've got to remember that I need to store D, O, G, and then this. So I'm going to need an array of size 4. Yeah, it takes space. It takes space in there. This is a whole character. It takes up a whole byte or a whole char. So we need that extra space. So if I know I've got 3 letters in my string dog, I need 4, an array of size 4. We don't want to display this. So if the user's told us their name is Sue, we want to print out Sue. We don't want to say, hello, Sue. That's just part of our array that we use to know what's going on. We shouldn't be printing that out to the user. If we try to, it's not even a proper printable character, and we might get weird stuff on the screen. So we don't want to print it. It's there for us to know actually to stop. Okay. All right, so how do we actually initialize these strings? Well, here I've got, it has to be of type char, and then I just create an array. Now you can put the size in here. If you don't put the size, C will work out the size from how many things you typed in. So in this case here, we've typed in HELLO, and we've explicitly put this in. We've done this sort of like the way we might initialize data in an integer array. And actually that gets really annoying very quickly because we're typing in all of these single quotes and commas. It's just a nightmare to type in any long string. So there's a more convenient way in C using the quotes. And we've seen these quotes before. We've done printfs and we've created strings to print out. The difference is we're now storing this string in a variable. And C is smart enough to know that if we have a string, it needs to put this special character in for us. So these two things will do exactly the same thing. Typically, we're not going to bother writing it like that in our code, but it's good to see that that is actually what happens and how our strings look. We typically just want to write it like this, and let's see, add this character for us and not do as much typing. Okay. Yeah, and C will work out from what you've put here how big to make the array. Okay, I can also, and we'll see more, I can also just ask for an array of a particular size. We'll see lots of examples. All right, how do we print these things? Well, actually there's stuff built into C to help us print our strings. We can just do printf%s. I can create a string, it can be in a variable, I can do printf%s, it will print it. But it's good for us to understand how it does that, and it's good for us to understand how it does that because we'll do other things where we need to go and look through all the characters in a string. So this is kind of how it works. So usually if I've got an array of integers, I'll do a loop pretty similar to this, but I will stop when it reaches the size. Like I'll say while I is less than size. Here we don't have a size. So we start at I is equal to 0, and we just go and we actually check in this string at index 0, what have we got stored here? And here it's an H. H is not equal to this, so we keep going through the loop and we move to the next one. And we're checking, is this equal to this special null terminator? No. And we keep going, we keep checking. In this case, when we get to here, word at index 5, it's going to check, is the character in here equal to this? And it'll be yes. And this while loop will stop. So it will literally check what's inside each one of these, and when it gets to here, it'll know to stop the loop. Okay. So we're going to do heaps of examples where we're reading them in instead of us hard coding them and all these sorts of things. All right, so that's how we can print them. This is how it works. This is how we really do it with %s. Let's do a bit of a demo of doing some of these things. Oops. Simple strings. Okay, so I've created a few different strings here. And I've done it in a few different ways, just to show us the variety of ways. Now the first one, I've got a string called favorite food, and it says KFC. So C would set up an array like this, and it would have, well, I've actually really explicitly spelt it out. I'm not putting the quotes in just to save time drawing. This is my KFC, this is my favorite food array. Favorite drink. Okay, I do it like that. C knows all about these quotations and strings. It will make sure it's got this null terminator at the end and make sure the array is big enough. We haven't specified a size, so it'll make it the exact size of the string we've said. Down here, I've said favorite book, but I have given it a size, and I've given it a size of 100, and I'm not going to sit here writing all the indexes. I'm just going to go like this. This is going to be, oops, I can't count to 3. This is going to have 100, room for 100 chars. We're going to have indexes from 0 to 99, and we're not using them all. We're just using some. We'll have folk of the faraway tree, and at some point here, somewhere in the middle, we'll have this null terminator, and everything after it will just be, spare space. Okay? And what would be the point of making this array bigger? If my favorite book is the folk of the faraway tree, why wouldn't I just make the string the exact size that I need? Yeah, I might decide, I hate that book now. That will never happen though, because I do love that book. And I might have another book, and it might have more characters in the title of it. So, if the value could change in your string, you might need to think about a max length for it. If I decided my favorite food was pizza, I'm not going to be able to fit it in my favorite food array. It can only store something with 3 letters in it. But that's fine, because my favorite food is not going to change. Either is my favorite drink. All right. Oh no, look, if I did suddenly think water was my favorite drink, that would safely fit in this array that currently says kombucha. But yeah, if I make it big enough for any data that I might get in the future, that's a good idea. And of course, I'm never going to know for sure. I have to sort of, with all arrays, we have to make our best guess of a reasonable size. Okay. And I can see people really asking great questions that we are going to get up to. Now, about having, like, what if we've want lots of strings and a variable that can have an array of strings? We will do that. Now, when we're dealing with these strings, we can treat them like whole strings, or we can go and look at the individual characters. So if I say favorite food at index 0, I'm going to, this particular character is what I get, and I can print it out with %C. Or I could say, let's go to favorite drink at index 3. That gives me the B, and I can print that out with %C. When I do that, I need that index because I'm going to a particular character. And I need to use %C because it's an individual character. When I'm printing out the whole string, I use %S, and I don't put any brackets here. I'm just passing in the variable name. This is just going to print out the whole string: favorite food, favorite drink, favorite book. So right now, this is all my program is doing. It's going to print out, a couple of letters from chosen indexes. Yeah, the K and the B. Then it prints out KFC, kombucha, folk of the faraway tree. Okay, what else can we do? Well, we've got this data in an array, we can go and change things if we want to. Okay. Just going to clean up a little bit. There, that's better. All right. So let's just make a few changes to some of our arrays. Now, if I go to, and these are just stupid changes that aren't achieving anything important, but if I go to my favorite drink and I say, let's make the one at index 0 equal to Z, it's going to go and overwrite this and put, hang on, I said favorite drink. It's going to go and put a Z in there. Why? Just as an example. Okay, so now if I print it out, if I save it, compile it, and print it out, I'm going to get Zombucha, which means nothing. All right, what about if I do this change though? I'm going to take my favorite drink, and at index 4, I'm going to put a Null Terminator. What am I going to get now when I print it out? So I'm going to index 4, which is here, and I'm putting a Null Terminator. Yeah, I'm just going to get ZOMB, because as soon as I get here, it's like, you know, a stop signal, stop, there is no more string. All of that now is just, we call it garbage. It's just garbage that's lying around in the array that's not used now. There could be all sorts of, you know, hidden strings in there. So if we do this, it will say zomb. And this is a really good way of just cutting off the rest of your string. Oh, I'm trying to run the program called zombie. Yeah, it's a good way of just chopping off the rest of your string. Now, the other thing you can do is you can accidentally remove these things, right? Imagine, for whatever reason, I'm not really paying attention to what I'm doing, or I don't understand how these work. And I think, oh, I can put, and I don't know what this would be, but I could put a D in here, for example. I could say, let's update favorite food at index 3. I'm changing it to D. Now what have I done? And what's going to happen? What do we think? Yeah, so a few people, yeah, I've gotten rid of the Null Terminator. It's technically no longer a string. If I try to print it out with %s, %s is going to be looking for this Null Terminator, and it's never going to reach it. And it's just going to keep looking and go past the end of the array. So when I try and do that, printf in good faith starts looking through, trying to print K, F, C, D, and then it keeps looking. And on our system, DCC, oh, this terminal's died. I don't know why. Hang on. This is simple strings. So now we've destroyed our KFC string, our favorite food string, I should say. And when we go to just run this code the next time, we've just compiled it, I hope. Oh, had I saved it? That's a good question. Let's just do it again in case. Now when we run it, when we print out our favorite food, like this is going to work. We can still go and get the K, but when we do this %s here, our program's probably going to crash. And DCC is pointing to this line. Oh yeah, it's going to crash down here because this is when I changed it. It was okay at the start. It did have KFC in it. We got down here, we put a D in it. When we went to print it out, it complains about this. And what is it saying? Stack buffer overflow. Yeah. Printf is going past the end of this array looking for this null terminator so it can stop trying to print. So it's going to break things, and anything to do with string functions, because we'll see more string sort of functions later, or even your own code, is probably going to break if you accidentally get rid of that null terminator. Okay. All right, now down here, I've got my favorite book, and Folk of the Faraway Tree is a kid's book, and I'm an adult now, and my favorite book is Programming in C. So I want to change my favorite book to be Programming in C, and I'm doing it like this. It's not letting me. Why can't we do this? So remember, these strings, they're arrays. They're arrays of characters. So I can't just say one string is equal to the other. I need to either write code that goes and copies them across, and we just did something like that for a 2D array. So I could do a 1D array that copies each letter from this string into here, or sets it one by one. Oh gosh, that would be horrible. But we're going to see later there's a nice function to do that. So I'm going to leave that for now and just show you that you can't do that. I'd have to just, I could go and change it up here right now. All right. Oh, we've already seen our own version of print string from the lecture slides. So I might just skip that. Okay. Let's get rid of this. Now, you might be thinking, okay, I can print strings with %s, and I'm sick of hard coding strings. I want to read some strings in myself. I want the user to type something in. I'm going to use scanf %s, and you'll try it, and unfortunately it probably will work. There is a scanf %s, but we don't want you to use it. So if you just do scanf %s in a similar way to how you'd use printf %s, you're not going to be making sure that you don't overflow your array. So, you're putting this, if you put this out to users, even if you tell them, type in a maximum of 10 characters, they might not listen to you. And then you might have a buffer overflow and crash your program, or in other cases without DCC, overwrite other data. Also, it's a classic way for hackers to get into the system by overwriting all sorts of data and really messing around with things. And you'll learn more about that in COMP1511 if you do any security courses. But it's, a famous thing called a buffer overflow. So we don't want to do that. The other thing is scanf %s may not do exactly what you want it to anyway. If you just use %s, it's going to stop when it encounters the first piece of white space. So if you were trying to type in Star Wars, you'd just get stars. So it might not even do what you want, but it's a security vulnerability when you use it in the typical way. And even so, if you don't care about all of that, it's forbidden in the style guide, so you actually lose marks if you use it. So don't use scanf %s. So what do you use? You use this thing called fgets. And at first you might think, I want to use, something familiar. But fgets has built into it a way to make sure that we don't read more characters than we can fit in our array. Of course, we have to put use it properly. So with fgets, you put the name of the array that you're reading it into, the size, And then you put this thing here, stream. So let's go through them. Yeah, the array is just the array that you want the string to be read into. The size is the size of that array, and fgets knows about strings and the null terminator. So if you say that this size is 10, they're only going to read in 9 characters. Fgets is only going to read in 9 characters from the user, and then put that null terminator in there. It's not going to let you overwrite your array. Actually, I think we need to go on a break in a minute. So that's what you put there. Then here, there's a lot of flexibility with this fgets function. You can read data in from all sorts of different places. For us, we're always reading it in from the user typing on the keyboard by default, and that's called standard input. And in our program, we write it as stdin. So for us, this will always just be stdin. It means standard input where the user's typing it in. Okay, so I think we'll have a break. We'll come back at about 5 past and we'll do examples using fgets. Okay. Okay, so about 5 past we'll come back. Okay, let's get back to it. I just was reading something about Boost Juice being $10. Is that what you're saying? Anyway, I don't know if I'm reading it properly. All right, let's get back into it. We're going to do some programming with fgets. Okay. Okay, so I've got enough, I've made an array of size 20. It's just an array of size 20. There's no, I haven't initialized any data in it. Just going to put these down here so they're out of the way. Okay, sorry, while my brain decides to come back from the break. Okay, so when we use fgets, and we might want to print something out, please. Enter your favorite movie. Okay, and then we do fgets. We put the name of the array in, which is movie. We put max, which is the size of the array. And then we just put stdi in. That's it. Oh, you've got to spell it right though. And then I can print it out. I can print it out. I could print something else, but that'll save my typing. And I don't do %d. I do %s because we're printing strings. Okay, so this is it. We do it fgets. Let's try it. Okay, enter your favorite movie. This isn't my favorite movie, by the way. The movie, yeah, Star Wars. And yeah, someone was talking about this before, but you end up with an extra new line. So let's imagine my favorite movie was Spy. And we've got our array of size 20. I'm going to get, I've typed in SPY, and now I'm typing in enter, which gives me a new line character. So this is what my array will look like. Okay, SPY new line, and then this null terminator. So basically fgets, when you use fgets, it's almost always going to get that new line character in there. And sometimes that can be annoying, and we'll talk about how we could get rid of it. The only time it doesn't do that is if you type in too many characters, because then it just cuts you off before you've even entered your new line. So imagine my favorite favorite movie was, I don't really know, I don't know all the names of these Harry Potter things, sorry. And the whatever, it's going to cut me off after I've typed in 19 characters, because then it wants to save that null terminator in there. Okay, Half-Blood Prince, yeah. That's what I meant, yeah. So then you don't get the new line because you haven't actually pressed enter yet. It's chopped you off. Now, as we see later, that string, you could still read that in another fgets if you wanted the second half of that string that the person had typed in. All right, but that's how fgets works. Now, what if I want to enter in, like let the user enter in lots of movies? I can put this into a loop. And how can we tell C when to stop? Well, we can press Control D. So the user can enter movie after movie after movie and press Control D when they're finished. And you've seen how to work with that with scanf, right? You can say if scanf, whatever, equals 1, we're still going to keep going through the loop. Fgets does it a bit differently. Fgets returns null if you type in Control D. What's null? It's just a hash defined value, it doesn't really matter. But for now, if fgets returns null, that means somebody pressed Control D and there's no more input. So we keep going while fgets doesn't return null. And what have I done wrong here? I've got this bracket missing. So this is how we do an fgets loop. We keep doing fgets while it's not returning null. And let's try this. So I say my favorite movie is Spy, Star Wars. Oh, I spelled it wrong. Star Wars, that's a good movie too. Harry Potter and the something. And we can see, actually, it ends up going through that fgets loop 3 times. It reads in Harry Potter and th. Then it keeps reading whatever it cut off. If I do another fgets, it'll still be in the that buffer, the standard input buffer. It'll then read as many characters as it can, and then finally it gets the ng and the new line. So it's had to do 3 fgets to get that in, and then eventually, I don't know what other movies there are. Barbie movie, whatever. I press Control D and it stops. Now you might be thinking, but have we stored all of these strings? No, we haven't. At any time, we've only ever stored one string at a time, and we keep overwriting it. In some situations, that might be fine. You're just reading in some command, you're going to do something with it, and then you can overwrite it again. In other cases, you actually want to store everything that the person wrote. So we'll have a look at how we do that in a minute. Oh, sorry, I'm just looking in the chat. All right. So yeah, Control D, it'll return null. We'll talk about what null is next week, I think. And it's just a signal to us, so we know that we should stop this fgets loop. All right. Now, what if I was reading in stuff through fgets and I decided I wanted to, for some reason that is inexplicable, turn all of the letters in the string that the person entered into capitals. So I'm going to shout it out back at them in capitals. I can write a function that takes in a string and then I can print it out. Why are we doing this? Well, I want to now also introduce, I already talked about that. I want to introduce some of these ctype.h library functions. And I also want to show you that you might read in a string with fgets, do something with it, and then, overwrite it again. It is relevant sometimes. So we've been doing all these sorts of things with individual characters ourselves. Like I can take a character and check if it's uppercase or lowercase by comparing it to, the character A and the character Z. I can do that to 2 upper and 2 lower magic where I'm taking my character, subtracting a capital A and adding a lowercase a and all that sort of stuff. There's also this ctype library, and there's more stuff in this library, and we're allowed to start using that as well. And these are just some of the functions it has. So let's just have a go at using it. So I'm reading a string in with fgets, and it's stored in this variable here. And imagine I did write spy because I've got a drawing of that. We're passing that string into capitalize. And remember, this is an array. It's not passed by copy. So I've got access to this original string. This is the movie array. So any changes I make in here are being made to the original string. So I can go through it, and I can do it with a loop as well. I can say int I equals 0. Let's keep going through this string while the current character is not equal to the null terminator. And then move to the next character. Okay, so this is how we would do the loop with a for loop, to go through every character in a string. Now what do I want to do? I basically want to change my character, potentially. I want to say SI equals something, in this case, the capital letter version of SI. And we just saw in the slide, there's a function called toUpper. So instead of having to do that, we could say SI equals SI, we do it minus A plus A, but what happens if it wasn't even a lowercase letter? That'll break everything. I'd have to check for it. So it becomes annoying. We can just say, instead of doing all that ourselves, toUpper. And it'll make sure it doesn't convert it to uppercase unless it makes sense to. So I've got to try and convert your question mark to uppercase. Now to use this, I've got to make sure I've hash included ctype.h. Okay. Let's try it. So yeah, spy, Star Wars, blah, blah. It doesn't destroy anything else. Oops. And then Control D to end it. The .h file is like a library file. It's called a header file. You might end up seeing that this term. I'm not sure if you're going to go into the details, but it just has, basically the .h files have a whole bunch of prototypes and hash defines in them, and we include them up here so we don't have to, you know, retype them in or copy and paste them in, is sort of how it works. Okay. So yeah, that's it for fgets. This is how you do fgets. Do we have any major questions or issues with it? Okay, so let's look at, there's a whole heap, and there's really a lot of these. There's a whole heap of functions that we can use on strings, and some of them are really, really useful and important, and you know, you'll definitely be using them. So to find the length of a string, to copy a string, to do a string compare. Now all of these things are things you could write yourself using some kind of for or while loop, but it's, you know, we just use them so often, it's much better to use the ones in the library that we know have been tested and debugged. So these are the common ones. There's also string cat. This can join two strings together. Strcpy, like it searches through a string for a character. We're not going to go through those today, and there's a heap more of these things, but yeah, we'll go through these really, really common essential ones. Okay, so string copy and string length. So I've got this variable here. It's a string. I've got given it some max length. It doesn't matter what it is. Let's just assume it's big enough to store this. And right now I've got an array of some max length with this in it. I should have done the colors different. This is annoying me. Hang on. Okay, so that's my string. I don't know how big this array is. Imagine it's like 100 or something. It doesn't matter. Now, you know, maybe I've just adopted this puppy and I've decided when he gets to our house, we're going to give him his own name. We want to change it to Finn, for example. We already know I can't just say puppy equals fin, that's not going to work. We either have to write our own loop to copy the letters in, or we can use string copy. So yeah, this is basically just copying the letters from this string into this array. Okay, so now it's going to copy in one by one. It'll just go through one by one and put all the letters in here. And we're going to end up with this. And that's fine, because anything after this character is considered to be rubbish. So now we've got our string fin, and it's living in this puppy array. All right, so that's all string copy does. You've just got to get it in the right order. I always think of it, we would write it as puppy equals fin. So instead of doing that, we just do strcpy and put a comma in it, right? So it's the same ordering as if you did it with an equals. Okay, so that's string copy. Let me rub that out. The other one is the length. So I can ask how many characters are in this string. When we get the length of the string, it's just going to go and count the number of characters that, you know, a person wants to store, really. So it's going to count the FINN. It doesn't count this in the string length. So the string length of this would be 4. Okay, that's all string length does, and this can be a handy thing to know. All right, that's string copy and string length. Hopefully pretty simple. You might forget every so often whether string length includes the null terminator in its length. All right, the next one is string compare. String compare can be a little bit confusing at first. String compare compares two strings. It returns naught if the strings are equal. So it's not doing a true or false kind of thing. It's returning naught to say there are no differences between the string. If we compare the strings and the first string is like less than the second string, and you might be thinking, how can a string be less than another string? But let's just talk about this, I guess. If I've got apple, we think of apple as being less than, say, zebra, because it sort of does like a dictionary ordering of these things. But we've got our ASCII codes thrown in, so capitals sort of are weighted differently. But anyway, most of the time we just care about whether these strings are equal or not. So what we can't do something like this. I can't say if name equals Oscar. I can't do that with a string. So if I had variables x and y and I was comparing them to an int, yes, I use equals equals. If I've got a string or in an array, I just can't use equals equals and ask. I could use a while loop and go and compare it myself. If I don't want to do that, and I don't, we use string compare. It will return 0 if they're equal, so I can use it like this. So this is going to compare Edgar to whatever string is in here. And given that that string says Oscar, it is not going to return 0. It's going to print out you are not Oscar. All right, so that's string compare. Let's go. I've got some code. It just basically does that. Let's have a bit of a look. Just to check. All right, we've got our puppy that changes its name from Boots to Finn. And it shows us that the length of that string would be 4 because it's storing FINN. All right. Down here, we're looking at string compare. We'll just do, And yeah, I've got the name Oscar. I'm comparing Oscar to Oscar. And we hope that it says, yes, they're the same, and it prints out, hi, Oscar. Here I'm comparing Oscar to Edgar. We're thinking it's going to say, you are not Oscar. Okay, so the first time it's equal, it returns naught. It prints out, you are not Oscar. Oh, the first time around, it is equal to Oscar. Sorry, I've got Oscar and Oscar. It's equal to 0. It says, hi, Oscar. The second time around, we're comparing it to Edgar, and it's saying, you are not Oscar. All right, what about if I do something like, I'm just going to print out less. Oops. And not less. Okay, this is saying that Oscar is not less than Edgar. What does that mean? Well, it's comparing it like we would compare sort of words. And if we were trying to do things in alphabetical order, we would have Edgar first, then Oscar, right? So this allows us to put things in order if we wanted to. So if it was less, I could then say, okay, well, if Oscar is less than Edgar, I could put Oscar first, then Edgar. Otherwise, I want to put Edgar, then Oscar kind of thing. Okay, so when I use the less than naught or greater than naught, I can just put things in order by knowing which one's considered to be smaller or greater, which is kind of a bit like alphabetical order, not 100%. Okay, now this last thing is just a little cautionary tale. So I've got another thing here. It's just another variable so it doesn't clash with the other variables. I'm allowing the user to type in the name, and they're typing it in with fgets, and then I'm checking whether they've typed in Oscar. Oscar's the name of my cat. Anyway, so let's type in a name. If I'm going to type in Edgar, of course it's not going to say it's Oscar. If I type in Oscar, it's comparing it to Oscar. It's still not saying it's Oscar. So I've done an fgets. I've typed in Oscar. I'm doing a string compare, comparing what I typed in, which was Oscar, to Oscar, and string compare isn't saying it's equal. What's happening? What's wrong? What's going on? Does anyone know? So what's fgets? Yeah, some people have worked it out. When I type something in and read it in with fgets, unless it was too long, we're going to have a new line at the end of it. So it's comparing Oscar new line to Oscar. So if I put Oscar new line and asked whether it's equal to Oscar new line, then it's going to say yes. Yay, Oscar. But sometimes we just want to get rid of these new line characters. They can be a nuisance. So what do? All right, imagine I've just typed in the word dog and it's got a new line, and I've typed it into fgets and I end up with this string. And I want to get rid of this new line. Now with fgets, you're either going to have a new line right at the end of the string or you're not going to have one. So this is going to be the location. How do we know what index this location is? Well, I can use string length. String length is going to say that the length of this string is 1, 2, 3, 4. And I know if my string length is 4, this is going to be at you know, 1 before the string length. This is where I find it. Now to chop off something in my string, I can just put a null terminator here and get rid of it all. Okay, so that's how I can get rid of my new line. So if we've got something like Oscar, oops, O-S-C-A-R. Now let's stay with dog. So when we're doing this, because we don't know for sure whether there will be a new line with fgets, typically we check first. So we can do something like int name length, and we can say string length, the name. And you know, if we typed in dog, the string, a dog new line, it would be dog new line, it would be 4. We want to go and check if the one at index 3 in this case, so the length minus 1, we want to check if that is actually equal to a new line character. Right? And no matter what our string is, in this case, if we get the string length and minus 1, that's going to be the index where our new line is. Okay. If it is a new line, we just want to destroy it. And because it's at the end, we can just chop it off like this. Okay. So this is a really common thing to do to get rid of a trailing new line if you have one. A new line at the end of your string. So now hopefully if I type in Oscar, we'll take that new line away, and when we compare it to Oscar, it's going to go yay. So this is code to remove a trailing new line character. It wouldn't have a new line at the end if I typed in so many characters that fgets cuts me off. So if I just kept typing lots of characters when I've used fgets, it's only going to let me type in 99 characters. So if I typed in hundreds of characters and then press new line, it's not going to have a new line character because it's going to cut me off. Yeah. But if I don't type in too many, or if I don't type kind of exactly as many as I'm allowed to, it's going to have that new line from when I press enter. So this is why we double check in case. So this is a common thing you might want to do. All right. What's the time? Yeah, we have time for arrays of strings. But before that, any kind of big questions about just strings before we jump into arrays of strings? Yep, there's a whole bunch of string functions, so you can use whichever ones you like. Occasionally, there might be rules like in a tutorial or in an exam where they will say, do not use the string library or do not use this function, because they might be testing if you know how to write that function yourself. But otherwise, yeah, you can use string case compare and other string things. Actually, there's no Kahoot today. I'm going to torture you with, oh, I've just pressed next. Okay. No, because I do want to do array of strings. All right. Oh, I'm sorry. I'm sure Sasha will do one on Monday. Okay. Oh, no. Look, I guess I could do one. We'll see how we go. But it'll have stuff we've just learnt. I guess that's okay. We'll see how we go, though, for time. So even before, someone was saying, how can I have an array of these strings? Well, here we go. We're going to do arrays of strings. So one string is already an array. An array of strings is a two-dimensional array. So I can declare an array like this. I'm saying, you know, char words 3, 5, whatever. This is going to allow us to have 3 rows and 5 columns. And in this context, every row is a string and the columns are just, you know, have the characters in the string. So here we've got string 0, string 1, string 2, which correspond to the rows. And we've got like the character 0, 1, 2, 0, 1, 2, 3, etc., which correspond to the columns. So we can visualize it as a 2D array of characters like this, and think of it and treat it and manipulate it by the character. Or we can just think of it as a one-dimensional array of strings like this. It depends what we're doing as to which one will be more helpful. All right, now if I take my array and I just use one index on it, so I go to this two-dimensional array at index 1, this is giving me this whole row. And this whole row in this case is a string. So I could say go to words at index 1 and print the whole string, and that's going to give me cake. Okay? Sorry, I'm just reading the chat. So I can get whole strings and use these things as whole strings, even though they're in this array of strings, which is a 2D array of characters. Okay, is everyone happy with that? Okay, we've got cake pictures, good. If I want to though, and so I can think of it like that as a whole row, or I can just think of it as an array of strings and just think, yeah, it's the one at index 1. Okay. I can also think of it, you know, in terms of characters by characters. So I can actually go to, you know, row 2, column 1, and print out the character from there. And that's going to give me an E. Okay, so it depends. We'll see different things where we want to go character by character or just string by string. Okay. Let's just do a little bit of coding with that. Oh, I'm going to the wrong one. Okay, so I've made my array a little bit bigger. This array can contain 20 strings. The strings can be a max size, well, the array is 10, but obviously our strings can only be 9 characters because we need the null terminator. At the moment, I've put hat, cake, and tea into this array, and I've kind of drawn it up here to sort of show you what it looks like. The rest of the data in this would just be all sort of zeros or null terminators. Now, I'll just go over what I said before. If I want to print out, you know, one of these strings, I can just, and my array here is called text. I can just say text at index 2 and print out the whole string. What's that going to print? So if I just go to this at index 2 and print it as a string, what am I going to get? Well, this is where it's helpful. Yeah, at index 2, yep, I'm going to go to row 2 and print out T, or I can just think this is word 0, 1, 2, I'm going to print out T. Either way, you're printing out the word T, like the drink, not the alphabetical letter. A bad example. If I type in 1, 2, that's going to take me to what letter? It's going to take me to row 1 letter 2, it's going to give me the K, right? Or I could just think here, word 0, word 1. Within this word, I go to 0, 1, 2, I get the K. So this is going to print out T, then K. Let's try it. Let's see what else I've got typed in here. I've got an unused variable, that's okay. Yep, it's going to print out the whole word T and the letter K. All right, what if we just want to print out the whole array? I've got code, I've got a function that can do that. Now, this is the thing where people sometimes get very confused. So I need to tell this function how many strings I've got. And you might be thinking, but we've got a null terminator. No, the null terminator means we don't have to specify how long every string is. So we don't have to specify that hat's got 3 letters and cake's got 4 and tea's got 3. We don't have to do that because every string we have has that null terminator. But we don't have a null terminator telling us how many strings there actually are, right? So when we've got an array of strings, each string has a null terminator, but we need to know how many strings are in our array. So I've got a variable that's keeping track of that. There are 3 strings in this array. And when I'm printing them all out, I have to tell it, I've got to pass in the array, and I have to say there's 3 strings. Okay. And when I print them, it's actually quite easy. If I don't sort of confuse myself with all of the details, I can just print it out almost like I would print out an array of integers. I don't have to think about all the characters. I can just use %s and go through each thing in my array and say, okay, print out the one at index 0, and it prints out hat. Print out the one at index 1, it prints out cake. Print out the one at index 2, it prints out T. Okay, and we're not even at that level of trying to print out the characters in all those strings. Printf %s is doing it for us. So let's try that. Oops, I haven't saved it. Okay, and that's printing out hat, cake, and tea. All right, is everyone clear on that? I know, and I made it, yeah, I should, yeah, anyway, it doesn't matter. Yeah, the T, which could be a letter or could be the word that's a drink, is very confusing. All right, now imagine I want to add something else. I've got hat, cake, tea. I want to add the word sun onto the end of this. I can't do this. I'm wanting to put sun in here. Oh, actually, I don't want to put it at position 4 anyway. I want to put it at index 3. I want to put the word sun like this. How can I do it? I can't say text at index 3 equals sun. Can we remember how we do this? So I can't sort of just say equals to assign a value into an array or a string. There are 20 strings in this array potentially. Yeah, I made it bigger. Yes, string copy. So I can't do this, but I could say, let's copy this word into this array at index 3. Okay, and now if I printed them out again, I might want to increment my num strings because I've just added another one. You know, I've added another thing to my array of strings. Okay, are there any questions about, now string cat is when we join 2 different strings together. If I wanted to create a word like cake, I would combine those two together. Actually, you know, sometimes we might want to take people's first name and last name and concatenate them together into one name. So we might take, if their name is Tina Arena, we take the Tina. We might then concatenate and add a space and then concatenate the Tina with the Arena to make it one string. And you might see that kind of thing in tutorials and labs. Okay, so that's basically arrays of strings. I am going to disappoint you all and not, I don't think we're going to do a Kahoot, because yeah, that's right. So we can join words together into one word as long as we've got enough space. So you'll practice using stringcat later. I want to just talk a little bit about command line arguments, even if we don't get to finish it properly. Does anyone actually know what a command line argument is? You wouldn't know it from this course, and I don't think most people do, to be honest. The average person doesn't know what it is. So we've been using these the whole time when we've been running programs. So when a really good example of a command line argument is when we're running something like DCC. The program name is DCC, but we're entering all this other stuff here, and these are command line arguments. So we're not running the program DCC and then it's sitting there going, please enter the name of the program you want to compile, and then we're typing that in. Please enter the name of the executable that you want to create, and we're typing that in. No, we just run it all on one line, and this gets passed into the program like before it's even started running. It gets it as soon as it starts running, it's pumped into the program. We can do that with our own programs too. So our programs have always had this int main void, and our main function has never had input, but we can have input. We can allow our main functions to have input from command line arguments, and we can have as many, well, there must be like some limit, but we can have many of them, and you know, different types, whatever we want. And the beauty of this is you can just go and copy and paste these, or use the up arrow and run things in exactly the same way rather than having to enter input. So sometimes this is the convenient way to do things for the user. So how do we do it in C? Well, suddenly we have a much fancier looking main function. We've got to have this. If we want to use command line arguments, we got to get rid of that void and put this stuff in here. And this looks a bit scary probably. Int, I'm sure you're happy with int, that's good. This stands for arg counter. This is telling us how many command line arguments you're given. This thing here that looks a bit scary, for now, let's just think of it as though it is like an array of strings, a 2D array of characters or an array of strings, just like we just looked at. You'll learn what the star means next week, but it's pretty much conceptually going to be the same thing for what we need to do with it here. So this is an array of the strings. So whatever arguments you got, they'll be in this array of strings. This stands for argument values. Okay. So if we do that and we run our program as follows, we're going to end up with an argc, which is our argument counter of 4, which sometimes surprises people. So it includes this in the count. So whatever you typed in to run the program, that's included as a command line argument. So here we've got 1, 2, 3. And if we want to have spaces in our argument, we need to put it in quotes. So this would be 1, 2, 3, 4 command line arguments. And they would all end up, so argc would be 4, but they'd all end up in our argv array of strings, like this. And note that this is the string 123, not the number 123. So if we've got a string that happens to have numbers in it, we can't actually do maths on it, right? It's a string, an array of characters. So we don't have to state it. When we run this, we will find out how many arguments we get because we get an array of them, and then we get told what the size of the array is. Okay. So let's have a look at how it works. So in here, I can say how many command line arguments I got by just printing out argc, right? That's just going to be an integer. Then the one at index 0 is always going to be the program name, or how, you know, whatever I typed in to run the program. So / something or other is how we typically run programs. If I just print out all of the arguments, I can do it with a loop because it's an array. And the size of this array is in argc. So let's try this. Let's just run it with hello 90. So it says there are 3 command line arguments. The program name is / command line args. It just takes what we typed in. Argument at index 1 is hello. The argument at index 2 is 90. Next time around, if we ran it, you know, we can type in a whole lot more. And now we've got 10 command line arguments, etc. Now, the problem is, yeah, this is my last lecture. Sasha will be back. The problem is next week. So I'll talk about that in a second. The problem is, yeah, imagine I did actually want to use my numbers as numbers. So imagine for some reason I was going to type in these command line arguments like this, and I wanted to be able to add all these numbers. I know they're numbers. I could try and do something like this: int sum equals 0. And look, I know that I don't really want to add on the name of my program. So if you don't want to print out the name of your program with your arguments or include it, you could start your loop counter at 1. Okay, but anyway, so imagine we're starting it at 1 and we're getting these numbers. And we try and add them onto our sum. This is going to fail because we're trying to add a string to a number. Incompatible pointer to integer conversion assigning int from char. So we've got one integer and we're trying to, remember, if I've got the number 1 as a string, I've got the character 1, whoops, I've got the character 1 and a null terminator. So I'm trying to do something like 0 plus this array. It makes no sense. So when we've got the string version of numbers, here, I'll get rid of this. We can use, and we always do if we're using command line arguments, there's a function called atoi. And atoi can convert a string to an integer. So this takes the string 952, which looks like this, which we cannot do maths on, and it converts it into just a normal integer 952 that we can do maths on. All right, so if I've got command line arguments and I need to add them up for whatever reason, I would just put my argument into atoi to convert it to an int. So Sasha will probably go through this again with you because I've done it sort of a bit rushed. So when I run it, you know, I can, let's not make it too hard for us to add up. I can pass these numbers. They get converted by atoi to actual numbers and we can do maths with them. All right. So this is command line arguments. If you need numbers, you need to use atoi to convert them to numbers you can do maths on, because you're going to get them as strings. All right, I think we've run out of time. Again, you know, you'll be doing a bit of a revision on this stuff next week with Sasha, and you'll be also going through it all in tutorials and labs. So we went through a lot today. Don't forget to have a look at that assignment walkthrough. Okay, feedback. Well, it's a bit late now. It's my last lecture. But yeah, Sasha will be back next week. So I hope you learn a lot more this term and that you enjoy all your coding. And you know, you all seem to be doing really, really well so far. So have fun for the rest of the term. And yeah, it's been great teaching you. So good luck with your assignment. Okay. See you, everybody. Thank you so much. Bye. Oh, yes. Thanks. Thanks so much, guys. Bye.